All right, so the way the short piece works is it's always the same as the original. Okay, we got a cubed plus b cubed. The short piece will be a plus b. We're going to do an example with numbers in just a second, and other letters. Okay, the long piece is the leftovers. Okay, it'll be a squared minus a times b plus b squared. Okay. Let this be example D. We'll have x cubed plus 8. Okay. It's got two terms. It's got an x cubed in it, not an x squared. It's got a plus sign in it, not a minus sign. So I know that if it's anything, it could possibly be a sum of cubes. So what I try to do is rewrite it as a sum of cubes. What cubed gives me x cubed? X. So this is a real simple one. What to the third power would give me 8? 2. Okay? So this is your A, this is your B. That's the way this is going to work. Okay? My short piece is going to be A plus B. X plus 2. All right? The long piece, I used one of the x's. There were 3 to begin with, so there are 2 more. So that's x squared. Then I'm going to multiply them together. X times 2 is 2x. It's a minus sign in there. And then the last piece, I used one of the 2's out here. I got 2 left, so that's 2 squared, which is 4. The long piece always has the opposite sign in the middle. Okay? So sum of cubes, plus in the short, minus in the middle of the long one. It's always plus out here because we're always squaring something. And anytime you square anything other than an I, you get a positive number, right? I squared is not positive, but we're not dealing with those at the moment. Let's do a tougher one. We're still going to follow all of the rules of factoring. We're still going to look for descending order. We're still going to look for GCF, and then get into the method. Okay. So anytime you see other numbers there, you've got to think, okay, maybe there's a GCF that would make this easier. 27 and 64. 8 goes into 64, but it doesn't go into 27 evenly. 3 goes into 27, but that doesn't go into 64. 9 goes into 27. Does that go into 64? Not evenly. 27 goes into 27. Does that go into 64 evenly? No. 54 it would, but not 64. So no GCF. It's only got 2 terms. One of them has an x cubed on it. So that makes me think, okay, if it's anything, it's a sum of cubes because it's addition. So I want to rewrite it. What cubed gets me 27 x to the third? 3 and then an x to get the x cubed. 3 times 3 is 9 times another 3 is 27. So that's 3 cubed. They don't generally get really large numbers that they want you to break down here. Okay? Cubes get big quick. 3 cubes, 27. What cubed is 64? I'm going to think about what's 64. It's 8 times 8, right? 4 and 2, 4 and 2. What's 2 times 2? 4 times 4 times 4 is 64, so it's 4. And generally you can just make a quick list of the cubes. 2 cubes is 8, 3 cubes 27, 4 cubed, 64. 5 cubed, 125. 6 cubed, 36 times 6. 180 plus 36. 216. They get big pretty fast. Okay? So we've got our A, we've got our B. Short piece. 3x plus 4. Whatever's in here plus whatever's in there. The long piece, this one's a little more difficult because you got numbers in there. Okay? So the first one is squaring whatever A is. So if I square 3x, that'd be 9x squared. It's a minus sign. What's 3x times 4? 12x. Last piece is 4 squared. 16. That's the factored form. I will tell you this. This trinomial will never factor further.
Are there any situations in which the squared number remains as it is and it's not simplified? Like, for example, if you have 4 squared, is there any situation in which you would have to leave it as 4 squared and not have it be 16?
No. Shouldn't be. You'd want to go ahead and simplify that number there, yeah. All right. Let's look at difference of cubes. Again, we're going to have something cubed minus something else cubed. Okay? Only thing that's changing is the sign in the middle. Still got a short piece, still got a long piece. The short piece is the same sign. That's A minus B. The long piece, all the parts are the same. A squared, AB, B squared, but it changes to a plus sign in the middle. Pattern is exactly the same except for the signs swap. So you learn this pattern. Factoring sums and differences of cubes is easy, but you've got to learn this pattern. Okay. All right. Let's get an example with some numbers. I don't know what letter we're on. F, not G. We prefer to skip the letter F, don't we? X cubed minus 27. Okay. Descending order, check. Is it got a greatest common factor? Oh, there's not enough stuff there to even think about that. Okay. Then we look at terms. It's got 2. So it could only be a difference of squares, a sum of cubes, or a difference of cubes. It's got a minus sign in it and something cubed on the variable. That tells me it's got to be a difference of cubes, if it's anything. Okay? So I'm going to try to rewrite it as a difference of cubes. Okay? What cubed is x cubed? X. What cubed is 27? 3. We already know that. Short piece, long piece. The short piece, A minus B. X minus 3. Okay. The long piece, x squared plus 3x plus 9. Square the first part, multiply them together, add, square the last part, positive. Add. Eight x to the third minus 125. They're GCF. There's more stuff that we kind of think there might be, but there's not. 8 and 125 don't have anything in common. So I'm going to attempt a difference of cubes. So what do we know about 8? 2 cubed. What do we know about 125? 5 to the third power. So that's a 5 right there. What's my short piece? Good job, Dan. 2x minus 5. What's the long piece? 4x squared plus 10x plus 25. Okay. Put something together. Don't quit. Now time to go. 2x to the fourth minus 54x. Descending order. Good. GCF. X and 2. Leaves us with x cubed minus 27. We've done that one already today, right? We know that that's a difference of cubes. So let's factor it. So we got the 2x in the front. We got a short piece and a long piece. What's the short piece for x cubed minus 27? X minus 3. A long piece. There's the factored form. We factored a 4th degree polynomial there. Pretty good. Pretty good.